So in the last class, we discussed what's the general form of divide and conquer recurrence. So this is general form of divide and conquer recurrence. Okay, here what does A denote? What does A denote? What does A denote? A denotes number of subproblems you are solving. Number of subproblems of size n by b we need to solve. Need to be solved. What does f of n denote? What does f of n denote? This is amount of time spending in divide step and combine step, and b is the amount by which the original problem size is reduced. Okay, no, if it is 2, it is reduced by half. Okay, no, something like that. Now after simplifying it by recursion tree method, okay, no, recursion tree method, we have got finally T of n is this. T of n is sigma j equal to 0 to log n base b minus 1. This recurrence relation, this expression, given recurrence relation, after simplifying it, we have got this expression. Now we'll proceed from this. So what is our T of n? T of n equals to sigma j equals to 0 to log n base b minus 1 a power j f of n by b power j, f of n by b power j, plus theta of n power log a base b, log a base b. The same thing, can we write it something like this? J equal to 0 we write separately. Then what happens? J equal to 0 case, a into f of n, a power 0 f of n by b power 0, no, plus sigma j equal to 1 to log n base b minus 1 a power j f of n by b power j plus theta of n power log a base b. What is this value? This entire value is nothing but it is same as a power 0 is 1, b power 0 is 1. It is same as f of n. Is that okay? Is that okay? So therefore T of n is f of n plus sigma j equal to 1 to log n base b minus 1 into a power j f of n by b power j plus theta of n power log a base b. So now from this, what can you say about order of growth of the T of n? What can you say about order of growth of T of n? Order of growth of T of n. What can you say about order of growth of T of n? Can we say that T of n is big omega of f of n? Is that correct? Is that correct? Is that correct or not? T of n's order of growth is greater than or equal to order of growth of f of n or not? F of n, we are adding some other terms. So definitely its order of growth will be greater than or equal to f of n. Or what is the other thing that we can say? This is one point. This is one point. So what's the other point? Can we say that T of n is big omega of n power log a base b? That means what is order of growth here? Order of growth is n power log a base b. Is that okay? That means, is this point clear? why I have written T of n is big omega of f of n? It means order of growth of T of n is greater than or equal to order of growth of f of n. Is that correct or not? Order of growth of T of n is greater than or equal to order of growth of f of n. Is that correct or not? Is that correct or not? If f of n is n square plus 3n cube plus 4n plus say n power 4. Not f of n, this is say T of n. T of n is something like this. What can we say about order of growth of T of n? So this is one function, different value. This is different value. This is another value, say. From this, what can we say about order of growth of T of n? Order of growth of T of n is greater than or equal to n square. Is that correct? Based on this. Similarly, based on this, what is that we can say? Order of growth of Tn is greater than or equal to n power 4. Based on this, what is that we can say? Order of growth of T of n is greater than or equal to order of growth of that is n cube. Do you agree with this? Is that correct or not?
Yes, sir.
Okay. So from this we know that order of growth of T of n is greater than or equal to order of growth of n power log a base b. Order of growth of n power log a base b. Is that okay? But exactly, we don't know what is the value. What is the order of growth of this expression? What is the order of growth of this expression? Okay, what is order of growth of this expression? And we also don't know whether f of n value order of growth is more or n power log a base b order of growth is more. That information also we don't know. Are you getting? We only know that T of n's order of growth is greater than or equal to f of n. We also know that T of n's order of growth is greater than or equal to n power log a base b. But we don't know what is the relation between order of growth of f of n and n power log a base b. All these details we don't know. All these details we don't know. Okay. Now, so in this case, here, if we are given different cases, something like this, say, if we are told that if f of n is big O of n power log a base b minus epsilon for some constant epsilon greater than 0. If we are told that f of n's order of growth is like this, what does it mean? What does it mean? F of n is big O of n power log a base b minus epsilon. What does it mean? Which has a higher order of growth? Which has higher order of growth in this case? Which has higher order of growth? F of n or n power log a base b? One side f of n, one side n power log a base b. Which has higher order of growth out of these two? If this condition is true.
N to the power log AB.
Log a base b. Thank you very much. Why? Because, for example, if f of n is say n square, n power log a base b is n cube. Even if I subtract some value, say 0.5, still n square is big O of n cubed minus 0.5. Is that true or not? Is that true or not? So now this we can consider it as f of n. This n cubed we can consider it as n power log a base b minus this 0.5 is epsilon. Is that okay? Is that okay? That means out of these two, which one has higher order of growth from this? Which one has higher order of growth? F of n or n power log a base b? F of n has strictly lower order of So from this, it is clear that order of growth of f of n is strictly lower than order of growth of n power log a base b. How much lower? I will come to that after some time. Okay. We know that order of growth of f of n is less than order of growth of n power log a base b. If this condition is true, what can you say about this entire expression? Order of growth of this, order of growth of sigma j equal to 1 to log n base b minus 1 a power j f of n by b power j. What can you say about order of growth of this? What can you say about order of growth of this? So any idea? Or simply f of n is this much. Then what is f of n by b power j? F of n is big O of n power log a base b minus epsilon. Then what is f of n by b power j? Wherever n is there, n by b power j we need to substitute, no? So what happens to the, for example, let us call this as g of n. What is g of n in this case? What is g of n? Sigma j equal to 0 to log n base b minus 1 big to big O of n by b power j into log a base b minus epsilon. Is that okay? Is that okay? Wherever n is there, n by b power j. What is this value? What is this value? This big O, we can take it outside. This I can write it as sigma j equal to 0 to log n base b. Even if you don't understand, you don't worry. Okay, no? Okay. So this is of the form a power m, a by b whole power m, a power m by n power log a base b minus epsilon, a power m by b power m, b power j into log a base b minus epsilon. Is that okay? Is this clear? A by b whole power m formula I applied. Okay, even if you don't understand, also still it's fine. Sigma j equal to 0 to log n base b minus 1 into this one, we can write it as, it is same as n power log a base b minus epsilon minus epsilon by, what is this value? B power j into log a base b minus epsilon. This can be written as b power j into log a base b into b power minus epsilon. Is that correct? B power j log a base b into b power minus epsilon. What is this value? B power j goes up and a comes down. So then it becomes a power j into b power minus epsilon. So this entire thing we can write it as a power j into b power minus epsilon. Is that okay? So this can be written as n power log a base b minus epsilon. It is independent of j. It is independent of j, so we can take it outside. N power log a base b minus epsilon, okay, no, into big O of sigma j equal to 0 to log n base b This can be written as b power epsilon minus epsilon goes means this is a power j, a power j, a power j. Okay, b power epsilon, it is a constant. So this can be written as n power log a base b minus epsilon into b power epsilon. Also, we can take it outside into b power epsilon into this is of the form sigma j equal to 0 to log n base b minus 1 into 1 by a whole power j, 1 by a whole power j. Okay, this is simple. We can probably go off. What is this summation? What is that we get? Whether it becomes constant or not? Can we rate it as it's a constant? Is it constant? Are you following, or is there any difficulty? Are you following, or so finally what happens to order of growth of this? This is definitely not more than n power log a base b, n power log a base b. F of n is lower than n power log a base b. This is also lower than n power log a base b, but this one is exactly n power log a base b. That means out of these three terms, which one has highest order of growth? N power log a base b. Hence, in this case, if this condition is true, then what is the value of T of n? T of n becomes simply theta of n power log a base b. Okay, even if you have not understood this proof, still fine. At least you can understand. How did we get this? That I tried to convince you. Okay, if f of n is big O of n power log a base b minus epsilon for some epsilon greater than 0, then T of n becomes theta of n power log a base b. That is one condition. One condition. So that's what I showed. Okay, this is the case. Similarly, if f of n is theta of n power log a base b, then what happens is at every level we have theta n power log a base b amount of work. At every level here, n power log a base b amount of work. N power log a. This is in case 2. Like that, how many levels we have? Here also n power log a base b amount of work. Here also n power log a base b amount of work. Here also n power log a base b amount of work. Here also n power log a base b amount of work. Like that, total how many levels we have? That means work is distributed uniformly across all levels in the recursion tree. That means total, what is the total amount of work done in this case? What is total amount of work done? In this case, case 2, f of n is theta of n power log a base b. That means each work is distributed uniformly across all levels. Uniformly across all levels. Across all levels. Is that okay? Work is distributed uniformly across all levels. Now, like that, how many levels are there? Level 0 to in the recursion tree. This is in the recursion tree. Level 0 to what is the last level?
Log n.
Log n base b. That means here also each level theta of n power log a base b amount of work. Like that, how many levels we have? How many levels we have? Log n base b plus 1. 1 to log n base b means log n base b. 0 level is extra. 1 plus log n base b levels. This many levels. And each level it is theta of n power log a base b. Then what is the total order of growth of this? It becomes theta of n power log a base b into log n. Is that correct? In case 2, work is distributed uniformly across all levels. That means each level n power log a base b amount of work is done. Okay, no. If that is the case, total there are log n base b plus 1 levels. So total work done in the recursion tree is n power log a base b into log n. So therefore T of n is this much. That's what is given here. And what happens in case 3? Another case is if f of n is big omega of n power log a base b plus epsilon, where epsilon is greater than 0. Now tell me, in this case, which one has a higher order of growth? N power log a base b or f of n? F of n or n power log a base b? Which one has higher order of growth?
F of n.
F of n, because here it is plus epsilon. No, f of n is greater than this. Not only that, if not only that condition. Okay, there is one more condition. Okay, this is missing here. And one more condition, a into f of n by b should be less than or equal to c into f of n for some constant c less than 1. Then we conclude that the total amount of work done in this algorithm, that is same as theta of f of n. That means the work done at divide step and combine step, it dominates all other works. That means in the recursion tree, the amount of work done at the root, it dominates all other costs. But this condition is important. This is called regularity condition. We will see this with the different examples. Regularity condition. Please, all of you, try to read these 3 cases. How did we get these 3 cases? This we call it as master theorem, no? So if you memorize or remember these 3 cases, many recurrence relations which are of this form, we can find their order of growth without even solving it. This master method or master theorem, it directly gives us order of growth without actually going for solving the recurrence relation. These are by considering different, comparing order of growth of f of n with n power log a base b. We have got 3 cases. First case? What is first case? First case is same as order of growth of f of n is, okay, let us take a new sheet. What is our first case? Our recurrence relation is T of n is a times T of n by b plus f of n. T of n is a times T of n by b plus f of n. Okay. Now, what does case 1 say? Every time we compare order of growth of f of n with n power log a base b. How many cases are possible? One is strictly lower than, the other one is equal to, the other one is strictly greater than. Is that correct? F of n's order of growth is strictly lower than n power log a base b. What does it mean? It is lower means n power log a base b minus epsilon. That means here lower means here not only some small value, it is polynomial amount lower. Okay, what is this polynomial amount? That you can understand. Okay, n power epsilon amount, it should be lower. That you will come to know, okay, after some examples. Similarly, what is this case? F of n's order of growth is same as n power log a base b. What is this case? F of n's order of growth is more than n power log a base b. That means even if I add something to it, some polynomial amount more. This is case 1, case 2, case 3. Once we know this, automatically based on this, we will get answers for T of n. What is answer in case of case 1? What is T of n in case of case 1? What is T of n value? What is T of n value? What is T of n value in case of case 1?
Big O.
Theta of n for all cases, final answer is in terms of theta only. Second case, what is T of n? Theta of n power log a base b into log n. Third case, what is the value? Sorry. Third case, what is the value? Third case, what is the value? Theta of f of n. Is that correct? Is that correct? Okay, one more time I read. What is case 1? What is case 1? Please tell me. What is case 1? Case 1 is f of n is order of growth of f of n is strictly lower than order of growth of n power log a base b. In that case, this is the answer. What is second case? What is second case? Order of growth of f of n is same as n power log a base b. This is the answer. What is the answer in this case? What is the condition here? Order of growth of f of n is strictly higher. Then answer is this. Is that okay? Okay, let us see with an example, then it will be clear. Say T of n is 9 times T of n by 3 plus n. Okay, plus n. Okay, initial conditions are not given. Even without that also we can find what is its order of growth. So now you tell me what is order of growth of T of n. In all cases, we need to find order of growth of T of n. So this is our reconciliation. Is it in the form of general divide and conquer? Is it in the form of general divide and conquer? Is it in the form of general divide and conquer reconciliation? What is A? 9. B is 3. And the f of n is n. And the f of n is n. Now every time what is that we need to compare? F of n and n power log a base b we need to compare. What is f of n here? N. What is n power log a base b? N power log 9 base 3. What is n power log 9 base 3? What is n power log 9 base 3? What is n power log 9 base 3?
N square.
N cube, sir.
N square. Thank you. Thank you.
Square.
N square. Now you tell me which case is applicable here. Case 1, case 2 or case 3? That means what is that we need to check? Okay, case 1 means is it possible to write n as big O of n square minus something, minus some positive value. Positive value. Some positive value. Case 2 means what? Case 2.
Then first you out type of
Case 2, what is? N is theta of n square. What does case 3 mean? N is big omega of n square plus some positive value. Positive value. You tell me, are there any among these three which is correct? Among these three we need to check no every time. Among these three which is correct? Can we say that n is theta of n square? N is theta of n square?
No, sir.
Directly we can eliminate this case. Now, can we say that n is big omega of n square plus some positive value?
No,
N
sir.
is big omega of n square itself is wrong, no? N is big omega of n square plus some positive value. N is big omega of n square itself is wrong. If we add something more, then n is big omega of n square. This itself is wrong. If I add something to it, n square plus 0.1. Is this going to be correct? Automatically, this is false now. So that means this case also is not possible. Now, what about first case? What about first case? Can we say that n is big O of n square minus some positive value?
Yes, sir.
Correct, no? You tell me what is the positive value here? So it appears to be correct. It appears to be correct. So n can be written as big O of n square minus some positive value. What is the value? What is the value? What's the value?
Epsilon.
Definition
You
wise,
tell me
it
n
can
square
be
minus
from
what?
0 to 1.
One value is enough. Epsilon, one value is enough. You tell me one value. That's all.
0.
Epsilon should be greater than 0. That is the condition, no?
Yes.
Always epsilon should be greater than 0. Okay. N is big omega of n power 1.9. Is this correct or not? N is big omega of n power 1.8. Is it correct or not? N is big O of n power 1.5. Is this correct or not? N is big O of n power 1.2. Is this correct or not? N is big O of n power 1.99. Is this correct or not? N is big O of n power 1.01. Is this correct or not? Are there any wrong answers here? Whatever I have written, is there anything wrong here?
No.
All are correct. All are correct only, no? You tell me one epsilon value.
హాస్టల్ చేతిలో ఉంది ఎంత కేజీ
N 1.9. N raised to 1.9.
Epsilon value
0.1. 0.1.
0.1. Thank you very much, brother. 0.1. Is this that means n we are writing it as big O of
అంటే చూస్తున్నా దగ్గర చిల్లర
1.9. We know that it is
లేదు.
correct. That means in the given form,
Target.
n power log a base b means we know that it is n square. N square minus 0.1 form, is it there or not? Is that there or not? That means what is epsilon value here you have given? What is the positive epsilon value we have given here? 0.1. Is that correct or not? Is that correct or not? Is that correct or not? No, these are asymptotic notations only. No, we are not doing anything new here. First to from second class, second class, third class, whatever we discuss, same thing I am discussing here. I am not discussing anything
ఎంత
new.
అవుతుందమ్మా అది
Anything new, only asymptotic notations, definitions only. N is big O of n square minus 0.1. Is this correct or not? Is this true or not?
True, sir. It is true.
That means here, what is the value of epsilon? 0.1 or not? That means which condition it is satisfying, which case it is satisfying,
ఎంత
which case it is
Yes, sir.
satisfying?
Case 1.
Case 1. So therefore, by case 1 of master theorem, MT means master theorem. Master theorem, what is T of n? What is T of n? What is T of n? Theta of n power log a base b, which is same as theta of n power log 9 base 3, which is same as n square. Is that correct? Is there any doubt in this? You please ask me if there is any doubt.
Can we take epsilon value as 1?
1 is not allowed. Epsilon should be greater than, if you epsilon value 1, that is allowed, no? It is 2 here. N is big O. This is also correct, no, brother?
It is satisfying, but is it correct to take epsilon value as 1? That is big number, no, sir? Generally, we take small values.
It doesn't matter. It doesn't matter. Only it should be greater than 0. That condition should be satisfied. That's all. There is no rule like it should be between 0 and 1. No.
Problems we take small values, sir. That is why I got out.
No, brother. Only definition, what does it say is epsilon should be greater than 0. That's all. 1 is greater than 0, no, brother. That's all. We go by the definition. That's all, no? Not only 0.1, even 1 is correct. 0.8, 0.8 also is correct in this case. Epsilon 0.8, is it correct? Is this correct or not?
Sir, we can take any value. 0 to 1, we can take any value.
0 to 1, any value, infinite number of values are there for epsilon. 0.1, 0.001, 0.0000001, 5, 6, like this infinite number of values are there for epsilon. One value is enough for us. Okay. So is this clear? If T of n is 9 times T of n by 3 plus n, what is T of n? What is T of n?
Sorry, sir. Epsilon range is 0 to 1 only, na, sir?
No, epsilon is only greater than 0, brother. Okay, I'll just to move to that slide.
If I'm taking, suppose epsilon is equal to 3, then what happened?
No, for some epsilon you should be able to find. Some epsilon, one epsilon you should be able to find which is greater than 0. Wrong epsilon if we take, that is there one value, positive value for which that condition is true. That's all.
Okay, sir. Thank you.
There may be infinite number of wrong answers, no, but
Okay,
is
okay,
there
okay.
one correct answer is the question now.
Okay, sir.
Okay. Is that clear, brother? See, here for some constant epsilon means some value we need to take for epsilon some value, so that this condition is true. It's not that whatever value we take for epsilon, it should become true. At least is there one value for epsilon, one value which is greater than 0 for which this condition is true. That is the meaning. It is there exists, no, there exists symbol, not for all symbol, no. Okay, we'll see one more example. Let us call it as example 1. Example 2, ditto but small change. T of n is 4 times T of n by 2 plus n. What is the answer? Please, all of you do it.
Theta of n square.
Theta of n square, correct, sir. Okay. What is A value?
Is 4.
A is 4, B is
2.
B is 2, F of n is
N.
And what is epsilon?
We can take say the same value, 0.1.
0.1 or 0.2, anything which is greater than 0 but less than 1.
Greater than 1. Greater than 0.
Greater than 0 will do, but epsilon we should not take a 2, or epsilon 10 I should not take. Why? Because for that the condition fails, no?
Yes.
Is it clear to all of you? Please do it. What is A value here in this example 2? A is 4, B is 2, F of n is n power log A base B is n power log 4 base 2, it is again n square. After that, whatever we have done here, same thing, no? Same thing, no? Is that okay? Is that okay? Is there any doubt? Is there any doubt?
No, sir.
Okay. So instead of n, if I give here 2n plus 3, 2n plus 3,
Same answer, sir.
2n plus 3, okay, n 2n plus 3 log n plus 5.
Answer, sir. We have to see order of growth only, no?
We have to
It
see
is
only its order of growth. Whatever extras we write, no, it's of no use. It's of no use. Finally, whatever the f of n is there, its order of growth only we need to check. Its order of growth only we need to check. Okay. Now, let us say third example, T of n is 9 times T of n by 3 plus n square, plus n square. Please, all of you do it and tell me what is A value, B value, f of n. Now you tell me which case of master theorem is applicable here? Which case of master theorem is applicable here?
Is 2.
Because f of n and n power log a base b both have same order of growth, no? That is order of growth is equal, no? Order of growth of this is same as order of growth of this. That means which case? Case 2. That means f of n is theta of n power log a base b, no? Which is nothing but case 2. By case 2, what is T of n? What is T of n? What is T of n? What is T of n value by case 2 of master theorem?
N power log a base b dot log n.
N power log a base b times log n. So by case 2, T of n is theta of n power log a base b into log n, which is same as n square log n. Is that correct? Is there any doubt? Is there any doubt? Is there any doubt in this? Example 4. T of n is 4 times T of n by 2 plus n square. What is the answer in this case?
Same, sir.
It is same, no? N power log a base b, it is n square. F of n is also n square. So others, are you following? And if there is any doubt, you please ask me. Both are same. So by case 2, again case 2, what is T of n? T of n is theta of n square log n. Now, example 5, T of n equal to 9 times T of n by 3 plus n cube plus n cube. Now tell me whether order of growth of n cubed is more or less or equal. More than n square or equal to n square or less than n square.
More than n square.
More than n square. So that means n cubed, is it possible to write it as big omega of n power 2 plus some positive value?
Yes.
Some positive value. You please, this is our epsilon. What is that we can write here? You please tell me what is epsilon value here? N cubed can be written as big omega of n square plus. You please tell me that value.
We can take 0.1.
0.1, 0.2, any value.
0.5 I'll take. Okay, all are correct, but why to take every time 0.1? I have written 0.5. Is that correct or not? Is that correct or not? So that means f of n is of the form big omega of n power log a base b plus epsilon form. Is that correct? This is of this form. Now, in addition to this, this is condition 1. Okay, now in condition 1, what is second condition here? A into f of n by b. That means which case we are in? Which case we are in? Case 3. Case 3, there are two conditions, unlike first two cases. A into f of n by b should be less than or equal to c into f of n for some constant c less than 1. That is the condition. Now tell me what is a value here? What is a?
9.
A is 9. What is f of n by b? F of n by 3. C means we have to find that c. What is f of n? N cube. What is f of n by 3? If f of n is n cube, what is f of n by 3? F of n is n cube, then what is f of n by 3? We know that f of n is n cube. What is f of n by 3? Wherever n is there, n by 3. Many examples we have done, no? Wherever n is there, n by 3. What is f of n by 3? What is f of n by 3?
N cube by 9.
N by 3 whole cube simply. Okay, no? Wherever n is there, n by 3. That's all. Less than or equal to some constant into n cube. N cube. This can be written as 1 by 9 into n cube. It should be less than or equal to n cube. But here, is it possible to find some value which is less than 1 so that this inequality is true. So that inequality is true. So that inequality is true. Is it possible to choose some value for that C, that is box, which is less than 1 so that inequality holds?
Here it is 1 by 3, no? 1 by 3 into 9 cube. The left hand
Oh,
side.
sorry. Hi, this is not 1 by 9, 1 by 3 only. Thank you. Okay. This is 1 by 3. 9 gets cancelled, 1 by 3. Is it possible to choose some value so that this condition is true?
Yes, sir. It should be greater than
1 by 2.
1 by 2. Thank you, brother. So if we take here 1 by 2, is it correct? 1 by 2, is it correct?
yes.
1 by 2, it is correct. Not only 1 by 2. 2 by 3, is this correct? Is it less than 1? Yes. 1 by 2 less than 1. 3 by 4, is this correct? Many values are there. One value if we give, that is enough. So what is our C value? We have taken C equal to 1 by 2. That means both conditions are, this is called regularity condition. This is called regular. Both conditions are satisfied or not? Both. But one important thing, if f of n is a polynomial, f of n is a polynomial, automatically regularity condition is satisfied. That means it has been proved that if f of n is a polynomial, regularity condition is satisfied. If f of n is a polynomial, then regularity condition is automatically satisfied. We need hereafter we need not check if it is polynomial. If it is polynomial, is that clear? Now, which by case 3 of master theorem, what is T of n? What is T of n?
Theta n dot a base b into log n.
What is T of n by case 3 of master theorem? What is T of n? By case 3, what is the answer? Case 3 of master theorem. T of n is theta of f of n. No? What is f of n here? And keep. Is that correct? Is that correct or not? So initial examples, no, that's why I'm elaborating and writing all steps. But after practicing some examples in not even minute, okay, no, in fact, in seconds, you will be able to answer this type of questions. Are we actually solving here? No. Only that master theorem 3 cases we need to remember. After that, we are plugging in the value and getting answer. That's all. Is that correct? Okay. Now 3 cases we have covered. 3 cases we have covered. In place of n cubed, here it is 2n cubed plus 5n plus 6. In place of n cubed, if it is 2n cubed plus 5n plus 6, what is the answer? In case of n cubed, if it is 2n cubed plus 5n plus 6, what is the answer we get?
Order of growth is n cube only.
So same answer we get. Finally, n cubed only we get. Only order of growth of f of n is important. What is the actual value here? It doesn't matter. Okay. Instead of this, f of n value is n into n plus 1 into 2n plus 1. If f of n is this, remaining part is same. F of n is this. Here, if we have here, still answer is same. Theta of n cubed only. Now, there are, in second case, again we have subcases. That is, what does the second case say? Order of growth of f of n is same as, order of growth of f of n is same as, order of growth of f of n is same as, order of growth of f of n is same as, in case 2, what is the relation between order of growth of f of n and n power log a base b?
Both are same.
Both are same. F of n equal to theta of n power log a base b means both have same. Theta means both are having same order of growth. Okay, now, both have same order of growth. But if f of n is of the form theta of n power log a base b into some log n, it is raised by some power, say k. Some power k. Okay, some power k. Log n into log n into log n, like that k times. And if k is greater than or equal to 0, answer is this. If k equal to -1, answer is this. We are generalizing case 2 now here. If k is less than -1, answer is this. That means, okay, we will see with an example. Example 6. T of n is 9 times T of n by 3 plus n square into log n whole cube. Now you tell me what is value of, what is order of growth of T of n? And what is A? 9, B is 3, and f of n is n square log n whole cube. Now, every time we compare f of n with n power log a base b. One side f of n, other side n power log a base b. What is f of n? N square into this is n power log 9 base 3. That is same as n square. N square. Okay. Now you tell me which case is applicable? Whether first case is applicable?
No.
Then you will understand why epsilon should be greater than polynomial amount more, polynomial amount less. That thing will be clear now. This is f of n. Can we write it as big O of n power log 2 minus some epsilon? Is it possible to write it like this? N square, same order of growth. That means what? Log n whole cube is there. If I subtract some value from this, whether this condition holds or not. That means what? Log n whole cube, whether it's order of growth is epsilon, if I take as say 1 by 2, then it becomes 1 by root n now. Is that okay? Log n whole cube, is it same as 1 by root n? 1 by root n, what will be its order of growth? What is order of growth of 1 by root n? As n tends to infinite, that value converges to As n tends to infinite, that value converges to
0.
0. That means, is it greater than n log n whole cube?
No.
Simple logic. This side n square into log n, some n square into some other value is there. Here we are subtracting something from n square. Whether this can be more than this, easily we can say this. No, it's not more. Even it is actually more than n square. Then if you subtract something from n square, automatically it will be less only. No. Is this correct? N square log n whole cubed, it is greater than big O of n square. Its order of growth is more than n square. Order of growth of this is more than n square or not? More than n square. Okay, if it is order of growth is more than n square, is it possible to write it as big O of n power n square minus epsilon? Impossible, no? It's impossible. If f of n is, now is it same n square log n whole cube? Is it same as n square? Is it same as n square? N square log n whole cube. Is it same as n square order of growth? Is this correct? This is also not correct. Now whether n square log n whole cube, now we know that we have understood that n square log n whole cube is more than n power log a base b. It is definitely greater than n power log a base b. Log a base b is nothing but n square. Is that correct or not? Is this correct or not? N square log n whole cube is greater than n square. Everything is with respect to order of growth. Is that okay? Is that correct or not? Order of growth of n square log n whole cube is greater than order of growth of n square. Is that correct or not? Are you following or not? Is there any
Correct only, sir.
this is correct now. Okay. Now, does it mean that is it possible to write? Is it possible to write it as n square plus some positive value? We know that n square into log n whole cube is greater than n square order of growth point of view. Does it imply that n square log n whole cube equal to big omega of n square plus some positive value? Is it possible to write it that way? If that is possible, then we will be in case 3, no?
Have to check other condition also for case 1.
We have already learned that log n power anything you take, its order of growth is strictly lower than n power 0.0001. This we learned, no? In general, log n whole power a, its order of is little o of n power b, where b greater than 0. Is this true? This we have discussed, no? order of growth of log n whole power a is little o of n power b. Order of growth of polylogarithmic function is strictly lower than order of growth of any polynomial function. Is that true? If that is the case, here if I add some positive value, then it is like nothing but n square into whatever positive value we add, that much, no? N power 0.1. If our epsilon is positive value is 0.1, n square gets cancelled. That means log n whole cube, is it greater than n power 0.1?
Yes, sir.
Log n whole cube, is it greater than n power 0.1?
Yes, sir.
No. Log n whole power anything, its order of growth is strictly lower than n
Lower
power.
than n power 0.0.
Lower, no. But omega means, what does it mean? This left side higher value should be there, no? Omega means.
Yes, sir.
But is it correct now? For any positive value, this relation is correct? No. This condition doesn't hold.
No.
That means now first case also is not true, second case is also not true, third case is also not true. Is that correct? Is that correct? Okay. For that, there are some special cases. What is the case? Okay, second case is false, okay, but in second case, this is some special. If it has only log n part extra and it is repeated, say, k times, as log n part extra and it is repeated k times, answer is whatever value is there, for that one more logarithm x will get extra. Log n power k, no, log n power k plus 1. Now you tell me which case is applicable here? Which case is applicable here? Which case is applicable here?
K greater than equal to 1.
No, greater than or equal to 0 case. This case is applicable, no? This we can call it as say 2a, 2b case, 2c case. Now which case is applicable? Which case is applicable in this case?
2a case.
2a case, no? What is k value? What is k value?
3.
Case 2a is applicable, case 2a, and k equal to 3. So now what is t value? What is t of n? What is t of n? Therefore t of n is
N square times log n power 4.
thank you, sir. Therefore t of n is theta of n squared times log n whole power 3 plus 1. Is that okay? That is 4. Is it clear? Is it clear? So that's why this is always no polynomial amount less or polynomial amount more. Okay, polynomial. That's why this master theorem doesn't cover all cases. There are gaps between case 1 and case 2. There are gaps between case 2 and case 3. For some problems, for some recurrence relations, it is very much useful. It does not mean that if we know this, we can solve all recurrence relations. How we can find order of growth of all recurrence relations. Master theorem, is it a method of solving recurrence relations? Does it give exact solution for recurrence relation? Master method? Master method or master
So
theorem?
it's you only asymptotic notation.
It only gives what is the highest order term in the solution or what is the order of growth of solution. That's all. That's why no, we need to, if we don't understand this, we need to memorize it. Okay. If you understand, then it's automatically based on recursion tree, easily you will be able to get these cases. Okay. Next. We'll see some examples. We'll see. Example say 8. If our T of n is like this, 9 times T of n by 3 plus n square by log n. N square by log n. Yeah, 1 second. Is that correct? Now you tell me what is the relation. Whether first case is applicable here. N square.
No, sir, it's k is -1 here.
No. Okay. Before moving on to that case, first we will try to understand why three cases are not correct, not applicable here. Then we will jump into that case. Okay. So n square by log n, can we write is whether it's order of growth and n square? Is it less? Is it less or not? Is it equal or not? Is it more? Is it less or not? N square by log n, is it less than n square or not? Order of growth of n square by log n, is it less than n square or not?
Not less, sir.
It is less only, no, brother. N square by log n. One side here n square we are dividing by some other value which is function of n. Definitely that is less than n square, no?
Not that, sir. If we take big n power 2 minus epsilon, sir, then
Okay. No, first to answer to question n square by log n, is it smaller than n square? Answer is yes. But what is the condition we require for that? Answer is no. What you said
our
is correct.
condition false.
See, first brother, n square by log n order of growth, it is lower than n square. That statement is correct or not?
Correct, sir.
Correct. But what is that we require in master theorem? What is that we require in master theorem? N square by log n, is it smaller if I subtract something from n square? Some positive value. Some positive value if you subtract, is it still holds? Is it still holds? If I subtract say 0.01, that means n square by log n, can we write it as big O of n power 1.99? No? Is this correct? N square by log n is big O of n power 1.99. Is that correct? Is that correct or not? Is that correct or not? This is false. This is false. This is false. Okay. Now n square by log n definitely equal to this is false. N square by log n greater than m square, this is also false. That means this case 1 is also not satisfied. Case 2, case 3, none of these are satisfied. But there is a special case. No, case 2, what does it say? F of n is of the form theta of n power log a base b by log n. By log n. This case is there, no? This is 2b case. Okay, the other slide it is there. F of n is theta of n power log a base b by f log n. Is it of this form? Yes, no? N square by log n, it is of this form. Theta of n power log 9 base 3 divided by log n. Is that correct? Is that correct? Is that correct? So therefore, because by case 2b, now what is T of n? Theta of n square into log of log n. Log of log n. Is that correct? That cases you need to remember. Okay, no? That cases we need to remember.
Sir, in this,
Tell me, sir.
yeah, before 2b, there are like 3 steps. No? 1, 2, 3 conditions.
Yes.
And first condition failed. second condition also failed. Definitely, third condition should satisfy, no, sir, because if
Yes, yes.
is
N
less
square
than
by
three or
n
is
square by log n, is it more than m square? Definitely, we know that it is not more. Because this is one value, no? N square by log n is some function. N square is another function. N square by log n, is it more than m square? It is definitely not more, no? N square by, we are dividing something by some value, then is it more than its numerator?
okay. So in that case, first condition should satisfy. Means suppose if I replace these two sides with a and b, suppose left side a, right side b, a is less than b, a is equal to b, or a is greater than b. Can we?
But here none of the cases satisfy. No, none of the cases are true here. Neither a less than b true, nor a equal to b is true. Neither a greater than b true, nor a equal to b true. Three cases fail.
Asymptotically, sir, it is asymptotically this one.
Asymptotically only. Whatever we are discussing, everything is asymptotically only.
So what is the base we are considering here, sir, for log n in this? Whenever base is not given,
Whatever base you take, any base can be assumed. It doesn't matter.
Okay.
Because n is there, no. Once n is there, what is the use of base? It doesn't matter, no. I don't. Is it clear, sir? Yeah, see, n square by log n, is it same as n square? Simple. Okay, no, this don't you forget about what is order of growth, all those things. Okay, 5th standard student or 6th standard student, two functions are given, n square by log n and n square. Both are same.
Yeah, both are not same.
Both are not same. Over n square by log n, is it more than n square? Two functions. Okay, no, you forget about order of growth, all things. N square by log n, is it more than n square? Numerator we have, denominator we have. That result, is it greater than numerator result? Never know.
Sir, in the case of denominator, suppose if denominator is greater than 1, suppose log n, if it is greater than 1, then the whole value becomes
Even
less
less,
than-
no. It is less, no.
Yeah. But if log value becomes less than 1,
No, but
then
base value, no, it depends on n is related, no.
yes.
Any base, if you give 20, then I can reduce it to small base, no.
Okay, yes, yeah, that
Write
yeah.
it in terms of small base. So your doubt could be something like this. So log n base 20, it is very small, so that n square value becomes more than n square by log n becomes more than n square. I think that could be your doubt, no, sir. In that case,
Yes.
what I'll do is
Yeah.
log n, I'll write it as log n into 20, 2 and log 20 into 2. Order of, now you come back to again order of growth. Order of growth, this we don't consider.
Okay.
Are you?
Yes.
Okay. So none of the cases apply. But again, so special cases also they have proved. They showed that if f of n is of this form, answer is this. Answer is theta of n power log a base b into log n. So log of log n. In this case, answer is log of log n squared into log of log n. Another, that is 2b case. Okay, in the previous slide, 2b case, log of log n. Okay, 2b, k equal to -1 case, no. This is same as k equal to -1 case. Now, okay, another example. T of n is 9 times T of n by 3 plus n squared by log n whole power 5. What is answer? What is answer? With the same reasoning, we can simply say that none of the three cases satisfy the condition, no? None of the cases satisfy the condition. Now we are in again
2B case.
2c.
2C.
K equal to -5. It is same as T of n equals to 9 times T of n by 3 plus n square into log n minus 5, no? Both are same, no? It is same as this. These two are same, no? Is that correct? Is that correct?
Yes, sir.
So now, which case by 2c, what is the answer? What is T of n?
Theta of n square.
N power log a base b, which is same as theta of
N square.
n square. Okay. Even if you have not understood the proof, all those things, then our worst case, what is that you can do is at least remember these cases, these three cases, and these two cases. Okay, no. Case 2 is already covered there. K equal to 0 is case 2 there. Okay, no? K equal 0, this case is same thing covered there. So here 2 cases, there 3 cases, 5 cases. If you remember, at least answers we will get, whether we understand or not. Final answer, correct answer we get. Okay, now let me ask you some questions. T of n is T of n by 2 plus 1. Please, all of you do it and tell me.
Sir, here number of subproblems is 1, sir. That is wrong. I think.
Then you forget about this number of subproblems already. What is A value, B value? We'll talk about that only, madam. Easy, no? A is 1, B is 2, and f of n is 1. A is 1, B is 2, and f of n is 1. Now f of n and n power log a base b we need to compare. What is f of n? 1. N power log a base b, n power log 1 base 2. What is any log 1 irrespective of base? Log 1 is 0, n power 0, that is 1. Now what can you say about the order of growth of f of n and n power log a base b? What can you say about the order of growth of f of n and n power log a base b?
Are same.
Both are same. That means f
Yes.
of n can be written as theta of n power log a base b or not. That is 1. 1 means everything, if you want, you can take in terms of n power 0. N power 0 is theta of n power 0. Is that correct? Now, which case of master theorem is applicable?
Case 2.
Case 2. So T of n is
N
theta
power log a into log n.
log a base b into log n. What is that?
Is 1 into log n. That is log n.
It is log n. It is same as this recurrence relation. In fact, we solved this
Binary search.
binary search this form, no? Loosely speaking, with some restrictions. Binary search, we cannot say that this is the recurrence relation. In the worst case, this is recurrence relation for worst case running time of binary search, not simply binary search. Binary search best case, that is different, no? Okay, it is only for worst case. Worst case. Is that clear? Instead of 1, if there is some constant, any constant 20. Instead of 1, if it is 20.
No change, sir. No change.
Instead of that, if there is simply, if they give some constant like this, simply plus some constant, Is there any change in the answer?
No, sir.
No change. Okay. So like this, you can practice many. What is the answer in this case?
Log in.
It is same as previous example, no? A equal to 1. What is B value? What is B value? 4 by 3.
4 by 3.
B is not 3 by 4. No, n by B, 4 by 3. And f of n is constant. Constant means simply we can consider it as n power 0. Now f of n on n power log A base B. N power 0. N power log 1 base 4 by 3. Both have same by case 2. What's the answer? Okay, I'm not writing details. Is that okay?
Yes.
No, sir. But she is in the very beginning side, she has to go a long way. Yes, sir, exactly.
In this case, what's the answer?
Yes, yes. Yeah. Yeah. Yes, exactly.
Now tell me which case is applicable?
Sure, sure.
Which case is applicable?
Thank you.
Which case is applicable? So first case, is it true? Is it log n? Is it more than n power 0? Yes. Is it polynomial amount more? Is it polynomial amount more? No. It is simply more, but not polynomial amount more. But not polynomial amount more. Is that okay? Is that okay? So similarly,
What is polynomial amount, sir? Can you please elaborate?
okay. For example, n cubed is there. We have n square. Is order of growth of n cubed? Whatever I say, everything is with respect to order of growth. N cubed, is it more than n square?
Yes, sir.
Is it a polynomial amount more or not? That is confusion, no? That is confusion. That means when do we say that it is polynomial amount more means if I add some positive value to it, some in power, no? That means Okay, I'll allow. Okay, 1 second. If I add some polynomial amount, say n power epsilon, that is nothing but n power 2 plus epsilon, no? That means I am multiplying with n power epsilon, no? A power m into a power n is a power m plus n. Is that okay? I am multiplying that with n power epsilon or not? Some polynomial amount I am adding to that n square or not?
Yes, sir. Yes.
Yes. N2. Now, if you can give some epsilon where such some positive value for epsilon such that this is more than this, then we say that it is n cubed is polynomial amount more than n square. Is it clear?
Yes.
Now,
sir.
is it possible to give some epsilon value here? You can give many, 0.5, you can give 0.1, also correct. Any value, okay, no? But epsilon equal to 2, this is not correct. Okay, one value if we give, that is enough. Is that clear?
Yeah, yes, sir. Yeah. Thank you. Yeah.
Okay. If you want a polynomial amount lower, for example, n square we have n power 2.5 I have. N square, is it lower than n power 2.5?
Yes.
Is it now n square I'll subtract some subtract means some polynomial quantity I reduce here. That means I divide it by n power epsilon. That is the meaning, no? By n power epsilon. That means what it is, n power 2.5 minus epsilon. Now, is that true? N square, is it less than n power 2.5 minus epsilon? Epsilon is always greater than 0. Is that true?
False.
I check one more time.
Oh, epsilon we can take from 0 to greater than 0 to 1. Sir.
Epsilon, if you want, you can take 0.1, no?
Okay, yeah, 0.1.
N square less than n power 2.5 minus 0.1, that is n power 2.4. N square less than n power 2.4. Is that right or wrong?
It is right.
Only.
If
That
I
means-
take epsilon 0.6, 0.6.
No, that's what I have made it clear. One epsilon you take where condition becomes true.
Oh, okay.
If that's why no condition here I also told there exists is the condition. If there exists at least one value for epsilon,
Okay, sir. Yeah,
where
it is
condition
clear.
is satisfied, then we say that yes, it holds. Whatever epsilon we take, it should not become true. It is not that like that. If at all there exists one epsilon which is greater than 0 for which the condition is true, then it is true. Is that okay?
Yes, sir. Yeah, I got
N
it.
square is
Thank
smaller
you.
than n power 2.5. Not only smaller, polynomial amount is smaller. Polynomial. Now, same thing n by log n. N by log n, is it and n you take? Is it smaller than n? Is it smaller than n by log n?
Yes.
Is it polynomial amount smaller? That means if I subtract some divide by epsilon, that means divide by epsilon. Now, is this true where epsilon greater than 0? That means n by log n can be written as it is n power 1 minus epsilon for any epsilon greater than 0. Can you give some positive value for epsilon so that this holds? It is impossible. No such value for epsilon is possible. Why? Because this epsilon, even if you put 0.01, then gone. No, this n here already n is there, so it doesn't hold. It doesn't hold. Here no epsilon exists. No epsilon exists. That means n by log n is smaller than n, but not polynomial. Polynomially smaller, but not polynomially smaller. Is that okay? Okay, I stop here. Again, we'll back by 6:35. Okay, 6:35. Okay, thank you.